The healthcare industry is at a turning point in the field of medical robotics. Innovations are being introduced every day, which inevitably push us into the future, where most of the work will be automated or performed by robots. Today, robots controlled by a doctor already have a huge presence in the medical field. The demand for procedures that are less invasive and more adapted to the needs of patients is increasing at an increasing rate. The medical field is on the verge of radical changes that could mean improved diagnosis, shorter waiting times, safer and less invasive surgery, increased long-term survival for everyone, and reduced infection rates, and much more. Next, we briefly present to you the 13 best achievements in the field of medical robots that are already changing our lives. This is the most common of medical robots, and today it is the standard for surgery using robots. This is a machine that blurs the line between a medical instrument and a robot, since the device is under the full control of the surgeon. However, the successes that this system has achieved are simply amazing. With the help of the Da Vinci robotic system, operations can be performed with minimal incisions and absolute precision, which means reduced bleeding, reduced risk of infection, and accelerated healing. Although the Da Vinci robot manipulator has been around for some time, it continues to improve. At the same time, several large technology firms are also developing similar Da Vinci systems with more autonomous characteristics and a wide range of capabilities. Endoscopy is a procedure in which a small camera is inserted into the body through a natural opening to search for tumors, lesions, or traces of disease. This is a very inconvenient and extremely unpleasant procedure that may soon be a thing of the past. The developments of companies such as Metaneering use flexible, thin robots that can be controlled like radio-controlled car models, in exact accordance with the needs of the doctor. They can be stably retained in the human body without trembling associated with fatigue of human muscles, and use a full range of tools, starting with biopsy and ending with cauterization of wounds. More impressive robots are called capsule endoscopes, in which the procedure is reduced to simply swallowing a pill-sized robot that passes through the digestive tract and helps take photos and collect data that can be sent directly to the processor for diagnosis. This is a newly developed robotic system created by a project team called MIRAB, MRI and Ultrasound Robotic Assisted Biopsy. This solution makes it possible to diagnose breast cancer at an early stage by a minimal invasive method. It increases the accuracy of the biopsy during diagnosis and allows you to reduce the use of expensive magnetic resonance imaging, MRI, to a minimum in this workflow, and at the same time ensure the same accuracy when targeting the needle during biopsy. The system combines the advantages of MRT and ultrasound. MRT is a very precise procedure that allows a doctor to find and puncture exactly the tissue that he needs during a biopsy. But MRT does not provide real-time images, and a doctor today needs to take several pictures to perform a biopsy procedure. In turn, ultrasound provides a real-time image so that the radiologist can see exactly what is happening during the biopsy. But this study itself is less accurate. But the combination of two technologies radically changes the picture. The robotic system scans the breast using a standard ultrasound sensor mounted on a manipulator and combines it with previously taken MRT images into one 3D model on the monitor. At the same time, volumetric and elastographic data are collected. The system then determines the injection site and the direction of movement of the biopsy needle. Over the past few years, incredible progress has been made in the field of prosthetics, and developers are trying not only to make a suitable limb replacement, but also to expand its capabilities where nature has not done it. At the MIT Biomechatronics Lab, researchers have created gyroscope-controlled robotic limbs that are able to track their position in space by adjusting their joints approximately 750 times per second. In addition, they have developed a bionic skin and neural implantation system that interacts with the human nervous system, allowing the patient to receive tactile feedback from the prosthetic system and control it as if it were a real hand. This is a significant leap in prosthetics, as well as a great hope for millions of amputees. Hope for the future because so far, such prosthetic systems are too expensive for an ordinary person. especially a disabled person. Robotic exoskeletons can be used in many medical fields today. To begin with, they are already being used to help people with paralysis walk again, which is a significant breakthrough in medicine. They can also be used for rehabilitation after spinal cord injury or traumatic brain injury, providing weak muscles with additional support needed to perform movements and heal injuries. Exoskeletons work by using a combination of preset movements. However, new developments are already underway with the development of neural interfaces. It's a matter of time before an exoskeleton controlled directly by brain commands becomes available to a large number of sick and healthy people. Hospital infections are a problem that our healthcare system has been trying unsuccessfully to solve for a long time. At the same time, hospitals use a large number of antibiotics, which can become a breeding ground for the development of some of the worst antibiotic-resistant bacteria. Therefore, it is extremely important that the hospital wards are always kept clean. However, this will never happen because lazy and error-prone people inevitably make mistakes that robots will not allow. The new disinfecting robots automatically move into an empty patient's room and bombard it with powerful ultraviolet rays programmed to work until the microorganisms are destroyed. These are very promising, although relatively new types of medical robots. The basis of their work is the use of mechanical particles close to microscopic ones to localize the drug or a specific therapy in a specific target area of the body. This technology can be used for narrowly targeted radiation of the tumor or simply to reduce the side effects of the drug, limiting it to the organ in which it may be needed. There are several possible methods for delivering such microparticles to a target, but new research has resulted in micro-robots with tiny spiral tails that can be guided by a magnetic field to rotate through blood vessels to a specific location in the body. The antibacterial bots are made of tiny gold nanowires and are coated with red blood cells that can remove bacterial infections directly from the patient's blood. They can do this by mimicking a bacterium and its toxins and then attracting and trapping them in a nanomesh. When the bacteria get closer, the work can also be directed through the patient's body using a special ultrasound to a specific location to speed up the cleaning process and treat localized infections. Since they use the natural reaction of bacteria, nanorobots can potentially be used instead of broad-spectrum antibiotics and can have a huge impact in our fight against the growth of diseases that antibiotics cannot cope with. Thanks for attention. Put likes, subscribe to the channel, and don't forget to click on the bell.